Okay, we're going to go ahead and talk about your final project. Before I get into that, how's the midterm coming?
Oh, well.
Extreme, I have like 4 more gray hairs.
4 more gray hair? Okay. So how far were you able to get, George?
I compiled it. I did a lot of research. And that's about it.
All right, well, I highly suggest you write up what you have and submit it.
You said we get bonus points if we throw you things that are useful, right?
Yes, you do. And saying use something else is not useful unless you have used something else that was able to get it working. See, watch how easy it is. Then that's useful. And of course, it's
So you're suggesting we submit it tonight?
yes, because I'm about ready to tell you your final project in 30 seconds or less.
LOL.
LOL. All right. The purpose of this project is to investigate if build root is compatible of capable. I don't know why there's an open close parenthesis there. Oh, I was trying to do an href and that totally failed. Is capable of generating full system images that are bootable with Gem5. Since this is the final project, I'm going to treat it as a research paper submission. Y'all have read plenty of research papers. I'm just expecting a similar format. You don't have to do the double column, but a similar, you can if you want.
I like those.
That's the only thing I like about them.
Yeah, really?
Abstract, single, everything else double.
Okay. So, all right, yeah, that's fine. Go ahead and do that. That's cool. I just wanted in that submission, I'll go and tell you a little bit more about it, or at least what I was able to tell you in the time I was able to write this. But we're going to investigate build root and Gem5. Hopefully, y'all know what Gem5 is, right? Anyone?
Garbage, yes.
No, that's you. Sorry, that came out totally wrong. All right, so it's a full system simulator.
So are we just doing build root stuff with it?
Oh, well, you're still going to have to get benchmarks in there. But yeah, you're still going to use build root.
That's the part I can't do.
Build root may come to your rescue. So what is build root? Well, here's the website. Actually, let's go to download. Hey, it's tar.gz. Sure, I'll go ahead and copy the link address. We'll get this started while we're here. Why not? tdr build root. Alright, so while that's trying to download. Alright, build root. Building an operating system from scratch takes a considerable amount of time. Build root offers a menu-driven system, there we go, that allows you to select what environment variables you wish to produce, and actually produces the whole operating system for you. So it's actually going to build a Linux kernel, package together a very simple, basic boot system, and goes into BusyBox, which is what Gem5 uses, if I recall correctly. Do they still use BusyBox? I hope so.
Yeah, I think so.
Good. And they also give you a cross compiler, so if you ever need to compile something for the system, you just use that, compile it, and then shove it on the image that they produce for you, which, by the way, has as much space on it as you decide to choose when you build everything with build root.
But don't we need this for the first project too?
No,
technically?
you mean Project 3?
Yeah.
No, you should have been able to have done that without build root. But if this ends up being easier, then that's what will happen for next time.
I thought we had to I thought we had to put the programs inside of.
Gem5 gives you its own tool chains online.
Yeah. Because that doesn't work.
They did for me. All right, tool chain. Hopefully y'all have seen this word before, at least a little bit.
To be fair, I didn't even get to that point because I couldn't get the full system to run it.
You are such a complainer. Keep in mind the programs compiled on your machine usually do not run in an embedded environment. Why is this? Well, the embedded environment might be a different architecture. For example, our machines are x86. It might be running ARM. It's not going to be able to execute those instructions. It could be a different operating system. You can't just take a Linux binary. Even if you're running x86, you can't take the Linux binary, throw it on Windows, and expect it to boot. You might have it compiled against different libraries. Yes, the the C library is a standard, but glibc's implementation and ulibc, uclibc, and the muscle libc implementation are all different. And of course, they're also compiled against different Linux kernels or headers, so those have to match as well. In other words, you really need to have the right tool chain for building programs for your operating system. To get around this issue, they give you a cross compiler which runs on your host machine, but produces binaries that run on your target machine. So it's a compiler that runs on your machine, like my laptop, and then can run on your target machine, which is what you would boot inside of Gem 5. Does that make sense, Matt?
Yeah.
You sure?
Yeah.
I mean, you were having some problems earlier. I'm just trying to help make sure.
No, I mean, like, yeah, this stuff seems good so far. I'm just questioning when it's going to get sketchy.
Remember, I'll tell you the sketchy part. I'll tell you it right now. All right, hints when using buildroot. Compiling time. Doing a full buildroot build is very time consuming. On my i5 laptop that I'm using, it can take hours. Since a simple mistake may restart the entire process, I highly recommend you start now and try an option every night before bed. Next morning, see what happens, and then try another one the next day. Okay? Otherwise, you're going to go insane trying to do this all day long because you're going to be sitting there for hours waiting for it to compile.
How big are the compiled things?
The final image, it depends. The ones I make are usually under 50 megs.
And this is the thing that takes a while compiling those. Okay.
That's the catch. Keep in mind you're going to need to use the tool chain to create anything to test inside your environment. All right, big instructions. This is an open research project that investigates the compatibility of Buildroot and Gem 5. You could come back and tell me it didn't work. I'm going to have to ask, I'm going to want a lot of proof of why that didn't work, because theoretically this should actually work just fine. Of course, theory and practice are different, but you're going to have to prove to me very well if it didn't work, why it did not work, and I want you to research why it didn't work. But chances are you're going to be able to come up with something that did work, or it partially worked as well. I will try and categorize what I expect from each one down here below, but before we get to that, let me see if Buildroot. Oh,
What does work mean?
it worked. It booted. I was
In
tired.
Gem 5?
Yeah, in Gem 5.
You should provide us a means to do that
To do what?
after the midterms due.
To do what?
To run the full system.
Why?
I don't know.
Well, anyways, so when you expand Buildroot, it's going to give you, well, a bunch of files. Let me help you out. Make space menu config. Oh, it didn't work. We don't have the header files. Oh, we need in curses. Curses! Looks like I forgot to install these packages. Let me do that real quick. Alright, make menu config. Okay. Make menu config, you can use this tool to configure Buildroot to tell it what you want to compile. For example, go target options. Maybe we'll go with, we have different chart. We'll do ARM Little Endian. ELF sounds great. That's the type of binary, extended Linux format. Architecture, wow, look at all these different cores we have. Sure, that sounds great. We don't need that. And ABI looks great. Floating ARM instruction set. You can include thumb if you want it, or standard ARM. Stick with standard ARM for now. Build options. I don't think any of these are going to be that important. Nope, we don't care about that. Well, hold on. Always make sure optimization level is for size. Otherwise, it's going to be really annoying. Toolchain. Toolchain type. Let Buildroot create the toolchain. Beautiful. C library. Okay. Your C library is the your implementation of libc. Libc is basically, you've used GCC. When you compile C code, you have to include like stdio or include stdio.h, string.h, math.h. Those are not part of a C compiler. Those are a separate library, all those header files and the implementation of them. As such, you need a separate piece of software in order to implement those libraries. And since it's C, you can pretty much guess that everything in the world depends on those libraries. So there are different implementations of a libc library, aka different implementation of stdio.h. libc, GNU libc is the standard that pretty much all Linux uses. The problem with libc is that it's a very large implementation because it's optimized for servers and desktops. For your embedded device, it's probably not the best bet because it's very large. While on the other hand, UC libc, next generation, is pretty small. Muscle is another implementation that I've seen them working on, but I haven't actually tested it yet. So if you do Muscle, it'd be interesting to see what you got. So I highly recommend you stick with UC libc for now. Everyone good with, everyone okay with my speech?
Yeah, go with UC libc.
Got it. Kernel headers, you can choose what kernel you want. Look at these options. So it goes all the way down to 3.2. So 4.15, sure. With Gem 5, keep in mind that you may need to drop down to 4 or 3.2. It's up to you. That may be one option you have to play with. ulibc, that's great. You can enable some locale support, but I don't compile it. I don't suggest it. binutils, that's fine. Oh yeah, binutils. If you recall, when building a compiler, you have your assembler, your linker, and your loader, or not your loader, yeah, your loader. Those are not part of the compiler. Those are binary, or those are standard utilities. binutils implements those standard utilities. They're very small. You can select which version you want here. That's what binutils is. GCC, you have different options. Well, you don't have too many with ARM, but that's okay. Looks like from 4 all the way up to 7. Why don't we go with 7 just for the fun of it? Sure. Don't include C++ support unless you absolutely have to. And by that I mean don't do it. You'll be very, very sad. Because you want, the thing about using Builderoo is you want to make your final image as small as possible because you don't want Gem 5 to be running any code that it doesn't need to. You may have to implement or get thread libraries in there since you'll be doing multiprocessing, or if you want to experiment with multiprocessing. And that should be thread library implementation. There you go, native POSIX threading. Okay, so that's great. Yeah, just leave that. Perfect. OpenMP and all that, you don't need that. GDB, again, that's more you don't need. MMU, sure, why not? So this just tells you.
You were talking about, but you weren't selecting them.
Mm-hmm.
You were saying we need
Okay, so I don't know where I left off, but it says thread library implementation, native POSIX threads. That's usually what your benchmarks use.
Right, so that's the type. But when you go back to the other menu, now that's not actually selected.
Yes, it is. It doesn't. It didn't put the box over here. You selected here because you can go down to none.
Oh, okay.
If you wanted to. Okay, great. Okay. System config. I think this should be pretty standard. There might be an option in here to automatically boot into some type of init system. You could always take passwords encoding to none or MD5. I guess that's all you got. Init system, BusyBox. Yeah, don't go with System 5. That'll take too long. Just stick with BusyBox because you want it to boot as fast as possible. Kernel. Put in the kernel. What do you want? 4.15. Very important, guys. The kernel you choose here has to match your toolchain kernel. If it does not match, your system will not boot. All right? Actually, I take that back. If it does not match, your system will boot, but none of your binaries will run. That's what I meant to say.
So the kernels that choices you had for kernel, you chose 4.15.
4.15 here. You can download a custom tarball and get it. And when you could download the 4.4.121 custom tarball. And if you did that, you need to go back up to toolchain and select 4.4.x kernel headers. The reason for this is when you compile your libc, which you see libc, glibc, or muscle, when you compile that, it's compiled against the Linux headers. So it has to know where your system calls are located in the syscall table and what are the size of your structures inside the kernel so they can use and implement libc.
So we still have to compile the kernel.
Yes, but Builder's going to do it for you. I'm going to hit make, and I doubt it'll be done by the time I'm finished, but you hit go and it...
Is it going to choose the configuration for the kernel?
Right, so we go to the kernel.
That's where I kept having to crap
You
out.
can have custom patches, configuration, use entry def config, use custom def config. This is where you'll have to do a little research. I haven't done this part in a while. I haven't done this because I usually, when I do build root, is I compile my kernel outside of it because it's just easier for me. But with this, you can do have a different kernel exploded somewhere, do all your menu configs inside your kernel, save that .conf, and then somehow load it in here, and it will use that configuration when trying to build.
Okay, so I still got to do the.
You have a help. I know it's not useful, but there's no help for that option. Oh, that's hilarious. No help for that option. All right. Okay. One thing I will tell you, build root, unlike Gem 5, has very good documentation.
Except for this one right here.
The online documentation. Sorry, the online documentation. Yeah, it doesn't have it right here. Sorry about that, guys. That's a lie. ZImage, you probably want to keep it. Maybe even want to go with unimaged. Yeah, we're going to go with oh no VM Linux. That's what we want. There. So there's no compression. Didn't we say no compression? Huh. Okay. Well, stick with the gzip because you don't want any bigger. Device tree, we don't want to do that. Kernel extensions, yeah, we don't want that. Tools, I doubt you're going to use any of these. Okay. Target packages. All right, you will probably not select any of these. This is if you want to include some package, although there might be a benchmark in here somewhere. I didn't even look. I mean, you can install Docker, ftop, what do we got? Kmod, great. Utils, Linux, okay, great. They've come out with system or default packages that you can compile and put in. Chances are what you're going to do, because I doubt parsec is in here, could be wrong, or any of your benchmarks, is you'll probably have to, once you have the image, mount the image somewhere, compile your binaries with the cross tools that was built with buildroot, and then put them into your image file. File system images, you can tar it, oops, excuse me. You can use ext2, initial ramfs linked into the Linux kernel, that works as well. This is where y'all are going to have to do a little bit more work because you're going to have to figure out how to, you're probably going to select this, ext2, and then figure out how to take a Gem 5 image and copy all the files over.
What? Repeat that?
You're going to have to use a Gem 5, Gem 5.
Yeah.
They have a tool to make an image that boots under Gem 5, right?
Yeah.
So you're going to have to create the image, and then what this does right here is they tar it up for you into a tarball. So you create the image with Gem 5. This gives you a tarball of your root file system. You mount the image, you copy everything, you explode that tarball into the root, and you're done. Does that make sense what I'm saying?
Yeah.
Oh, okay, yeah.
Yeah, there's going to be a rootfs.tar.
On the,
Okay, so
Jason
it's just
low power page.
What? I'm sorry?
Jason low power. That
our doctor friend in Wisconsin. You don't know who we're talking about?
Mm-mm.
Surprising. So all it's doing though is it's taking the stuff that it's making, tarring it up, and
Yeah.
then we're shoving that in the Gem 5 thing.
You got it, yeah.
Okay. From the way you worded it, it sounded like we were doing the exact opposite of that, so I was really confused.
Oh, I'm sorry.
Yeah.
My apologies. You might be able to get this to package it all inside of an image for you, but I doubt it. Well, you can put it inside an image and then boot it with QEMU, but I doubt it'll boot inside of Gem 5.
The Gem 5 image tool will not run on the latest, so you need to use 14 or earlier Linux.
What do you mean, 414 or?
No, I'm talking about Ubuntu version 14 or earlier.
Oh, I see.
Oh, no, wait, so you're saying this tool wouldn't even run on the newer ones?
No, the F disk uses the dash D, capital D, and capital F, and they've been deprecated in the later versions of Linux.
Huh.
So to make it easier, go back and install an earlier copy of Linux.
I might have shot myself in the foot by downloading the latest version of Mint to use.
You don't need a bootloader because Gem 5 does it for you. Okay, more utilities, don't care, and then, yeah, those don't matter as well. All right. So hopefully you can see there's a lot of options you'll have to research. I've gone through at least the big ones for you. When you're done, you just exit. Do you want to save it? You hit yes. You type in make. You wait a minute because it's going to go crazy trying to configure everything. And if you didn't mess anything up, no kernel def config name specified. All right, let's see what we did. Linux kernel def config. I said use entry. Isn't that what I said? Why would that be an issue? Wow, it's already failing us. There it goes. So it's going to now, and over here, download every single package and compile it. So it has started the full build. All right, back to this. We'll see if that gets done in time. I have no idea. I actually, by deselecting C++, that's going to save us a ton of time in compiling. So it may get done in time. All right, as I was saying, there's basically three possible outcomes here. One, it didn't work, aka you could not get build-root to create a full system image that Gem 5 could boot for you. Or that's one. Or it did work, aka you were able to get Gem 5 to boot an image from build-root, or it partially worked, like you were able to get part of it to work and partly not. So if it worked, which is what I expect to happen after some long nights and crying and some loss of sleep, sorry guys. But if you start early, it won't be that bad. Make sure you give me your def config or .config of build-root, submit that to GitHub. That way I can pull it in, put it into build-root, hit go, and it's going to make the exact same thing you selected. That's going to be one of the best pieces of documentation for me.
Can I not just give you the 250 megabyte file?
No, because if you give me the .config, I can build it and manipulate it as I want.
Spooky.
Additionally, in your paper, explain at a high level what options were selected and why that worked. You don't need to tell me every single thread option is selected, but high level, we did put in C++, we did use UC libc, Linux kernel version this, GCC version that, etc. Yes?
Do we only have to do like one of these technically? Well, three, because you say three different.
There's three different options, so whichever one option worked, I want you to tell me. Remember, this is an open research project, so I'm telling you right now, since it's an open research project, I don't know if it's going to work.
Okay.
Okay?
Okay.
All right. I knew that the midterm thing can work because I've done it before. This one, I do not know if it works because I haven't done it before, but part of being a master's student is actually doing some research. Okay?
Oh well.
All right. All right. Tell me what GCC you used where it worked, aka where you were able to boot a build-root image from Gem 5. What libc you used. Also tell me what version of that libc. What architecture you compiled to. Reviewing Gem 5's website. Since I think we've had some problems looking at it. It looks like everyone immediately went with x86, which I can tell you is a terrible decision.
I actually went with ARM first, but then there's no out of order for that. So then I went to x86 and then Sadness ensued for the next
Okay.
48 hours.
All right. If ARM only does it in order, that's okay. We'll just stick with that.
Wait,
for this project.
for the new one.
For the new one, yeah. For the old one, no, but for this one, yes.
Cool.
So Alpha, keep in mind that they want a kernel 2.4, 2.6. Alpha hasn't really been updated in a while. ARM is probably going to be your best bet because it can boot unmodified Linux. That means you don't have to apply any patches to Linux to get it to boot on your Gem 5. Gem 5 just boots it, which is great. And apparently it boots Android as well, which is actually pretty amazing. Spark. Fortunately, Spark is dying. It's really sad they do all this work to finally get Alpha and Spark running, but both of them are being tossed to the wayside, right? Oh, wow. Both of them are? Yeah. Alpha is basically dead.
Oh.
Alpha is dead. Spark...
I thought you meant Gem 5 and Spark.
No. Spark is all but dead. What? Dying. A very painful death because Oracle just doesn't care.
Is it going to turn into a black hole?
Probably. And x86 is just a nightmare. Yes. So that really just leaves ARM, maybe Spark, an Alpha, and maybe Builder can actually give you a nice Alpha build. You probably want to use Alpha GCC version 2 if you can, just FYI. But yeah, those are your options. x86 I would use as a last resort, a very last resort. By the way, this is 32-bit, not 64.
What? Well, that might be a problem.
Okay, this is not 64-bit. This is 32-bit. Don't try and run 64-bit. Only sadness will occur.
No way.
Yeah, that's 32-bit.
I still got sadness with 32-bit.
x86_64 is the 64-bit extension, or AMD 64 is the 64-bit. But when you see x86, that's 32-bit.
Son of a...
Nice stop. Nice stop.
Biscuit.
Biscuit. Thank you. Thank you. Whew. All right. Again, this is something to document in your midterm, so I know how to update that file for future.
Did you get any benchmarks?
I got them to run, but not in the proper. I'm still running them actually.
Cool.
No,
At
okay.
speed, but they don't support the DDR3, so I'm
Let's use a different memory then. Yeah.
So I'm hoping you'll give me another day.
Sure.
We got class till 9 o'clock tonight, so I mean,
You can have another day. Yeah. You can have another week really with the midterm, but we can't push this thing anymore, right? This cannot be pushed out anymore.
This thing doesn't look bad, except for the part where it says to run some more of the benchmarks.
What benchmarks were you able to run? Yep, there you go.
Yeah, there's my.
Because this is the partial thing. You might be able to get
Kryptonite.
a system up and running, but you weren't able to get a benchmark to run. That's possible. I doubt it, but it's possible. What benchmarks were you able to run? Again, just like previously, get 3 benchmarks up and running inside of Gem 5. We're able to get multi-core working inside of the build root because sometimes that can have some issues building your own image with multi-core.
multi-core. They really don't have anything in there for separate cores unless you pick the chipset, I guess. Is that how?
I would have to
They don't document it as multi-core anywhere except in one obscure place where the number of CPUs is apparently the multi-core.
So there's multi-core and multi-processor. Both are acceptable in this situation. If you want to have a CPU with an L1 cache and multiple CPUs that each have their own L1 cache and hook them together with a bus and connect back to a level 2 large L2 cache, that works as well.
Okay.
Okay? What? Yeah.
They're not calling them cores, I don't think.
They call them processors? That's fine. You can call them processors, same thing. Well, it's not the same thing, but close enough for everything, our purposes. Please ensure you try 3 different ISAs. Make sure I say the word try. You can just say x86 only gave me issues, ARM worked, Alpha I tried a little bit, I did these things and it didn't work.
Which ones are least likely to work?
Least likely to work? x86.
And
Also, MIPS is not going to work. That one shouldn't be here because they don't have MIPS support. I don't know why that's
so freebie.
Yeah, so that's a free. Well, I need 3. No. ARM is probably the most likely to work. I worked with a guy that did ARM into Gem 5, and he was actually intelligent, so I have a good idea ARM's working. Alpha and Spark, who knows? I got Alpha working, and it wasn't, there were some headaches to it, but not a lot. It was really just getting the cross compiler compiled, and I didn't have Buildroot at the time. I had to do everything by hand manually. But if Buildroot automatically gives you a tool chain with Alpha for Linux kernel, was it 2.6 in GCC 2 or GCC 3, Alpha is going to run like a champ. I can tell you that right now.
So you're saying use Alpha for the
If Buildroot gives you those options, because if you can into Buildroot, Alpha's going to run like a champ. It's going to be great, because Alpha is the first thing they implemented. Because out of all these ISAs, Alpha is the easiest, the most straightforward, the most simplest one to get working and up and running. Probably Spark is probably a little more complicated. So probably the other one that doesn't work. Well, maybe I just don't know how their support is. They may have completely dropped their support for Alpha, in which case the whole thing's broken. Don't know. I looked inside and they're still developing it, so it's being maintained.
What about Gem 5?
Gem 5, I'm sorry, still being maintained.
Well, the Alpha will run because that's what I'm running.
Okay, great.
Alpha with the old kernel.
Yeah. Oh, yeah. If you can get that too, get the, like I said, Buildroot gives you kernel 2.6, GCC 2, or maybe GCC 3. It'll run like a champ. Okay. Option 2, it didn't work. aka you cannot get Buildroot to create an image that Gem 5 would boot. You must show me Buildroot's not capable of building images for Gem 5. If you just say it didn't work and tried a couple of options, your grade's 0. While this option is possible, I do find it unlikely, although I will admit it's impossible. I mean, it is possible. I just find it unlikely. You're going to have to give me a lot of documentation of all the options you showed. You would probably need to send me a lot of .configs of your different options you've tried. You need to give me all the error messages you got. You need to inspect Gem 5 and say, like, they did not implement this feature, which is why it won't boot. Something along those lines.
Can this be an alternative for the midterm as well? Because I got all kinds of errors.
Like I said, for your midterm, the more you document about this error, I saw this error, I fixed it by doing this, the higher your grade will be. What GCC versions did you use? libc, architectures, what error, explain what the error means, how could you get around the error, why is this not feasible? I will accept I would have to develop Gem 5's solution to this as why it's not feasible, because you don't have 2 weeks to go edit Gem 5 and implement out the rest of Alpha or the x86 instructions they didn't implement. That's why it's not feasible, because you only have 1 month to do this, right? But if you started this the night before and you're like, I just couldn't get it to work, that doesn't count. You'll see the difference here? Okay. I just want to make sure it's clear, because I don't want anyone to jump to this one. This should only be the last resort, like for really the whole system is this bad. I doubt it's that bad. Also, what other options are there? I forgot to put a partial works, but if it partially doesn't work, it's going to be some combination of these two, right? Partially work would be like, I got the kernel to compile, it can boot, it can use the kernel, but I can never get it to get the rootfs working, or maybe vice versa. Maybe there's a problem with the tool chain, but the other tools worked out just fine, etc., etc. All right, some hints. Compiling time, like I said, doing the whole Buildroot is very time consuming. See, it's still going. What is it doing right now? Let me see. It's doing the initial GCC. Have any of y'all done a cross compiler before? Oh, it's I want to say it's a hoot, but it's so GCC is written in C. Think about that for a moment. GCC is written in C. So in order to create GCC, you need a compiler, but GCC is the compiler. All right, now we got that taken care of. Step 2, in order to compile a full GCC, you need to have libc installed. But in order to compile libc, you must have a C compiler installed. All right, everyone, have I lost anyone yet? Have I lost anyone yet? Okay. Do you see what the problem is with this? If you need libc in order to compile a C program and your compiler is written in C, how do you create the compiler?
Chicken and the egg.
Yeah, it's the chicken and the egg problem. So what's going on over here is there is a bootstrapping problem. Hey, got the initial one done. Where they have the initial GCC, which is kind of like stage 1 GCC, which is a, it will not compile your C code. It only compiles a small enough subset of C in order to compile your libc package. And once you have that, you can use the libc that you compiled and the bare bones C compiler to produce a final GCC. So you create a mini GCC, use that to compile your libc, then you use that libc that you created and mini GCC to actually compile the final GCC, which is then what you can use. So it's like a Texas two-step or a side-step or something. You know, it's a weird little process. So when you see GCC being compiled twice, that's what's happening. And in Builder, I think it was called a GCC initial and then final. Right now it's compiling, oh, this is libc. You can see it libc, it's compiling it right now. Great. All right, other hints, GCC option, that's your compiler. They don't have other C compilers available. By the way, it's actually a GNU compiler collection. It will do Fortran, C++, etc. But for this project, I highly suggest you stick with C. Otherwise, trying to load up the C++ library is only going to cause sadness. Fortran, on the other hand, will work out very well if you need it. That one is nice and small footprint as well. Keep in mind, some version of GCC will not work with certain kernels and libc. I cannot give you the matrix of what that is, but I can pretty much guarantee you that if you try and take the latest version of Linux 4.15 and you try and use GCC 2, it's probably not going to work. Okay? So you just have to play with it and figure out what's going on. That's just life. libc is standard C library. It's basically the library for what everything uses to run. While GCC is the most compatible, it's very bloated, so I highly recommend UC libc or Muscle. I always stick with UC libc for now. Linux kernels. Keep in mind, old kernels may be more compatible because Gem 5 probably hasn't been updating everything to stick with the Linux kernel, but that doesn't mean the latest Linux kernel won't work. You probably just need to disable certain kernel options when you go to compile the kernel. Also, keep in mind, you can try and use Gem 5's own kernel, but if you do, remember when I had that libc kernel headers? You must make sure you have the correct kernel headers around that matches what Gem 5's kernel headers were.
So if we don't want to compile the kernel, we can find one to match us, we can use it?
Yes, you can try that as well.
Good.
But right now, what's it doing? I don't know. It's doing some sort of configure, so I'll have to go back and check. All right, benchmarks. I took this directly from your midterm, verbatim. You need to evaluate 3 benchmarks. Keep in mind, Splash 2 has 8 apps and 4 kernels for a total of 12 benchmarks. Try and compile different ones, get them in there. Pi calculator, parsec. There's other ones out there as well.
And will they run in an in-order simulator?
They should, yeah. Yes, the answer is yes. They should run in Atomic as well.
Okay.
Because the only difference is that the order they're going in. Now, I say that there is one thing to keep in mind. When you do in order or out of order, if the code was not written correctly, it may work for atomic mode, but not for out of order mode. If you experience that and you dig through the errors and you believe that's the case, make sure you confirm that's the case and then say why. I have a hard time believing that it's not a configuration error with Gem 5. All right, what are we compiling now? We are doing G++. Looks like it's doing the, okay, so it's doing the final G++ compile. Wow, this might actually get done. Okay, what's needed in the paper? Y'all have read papers with operating systems, so I'm going to follow a very similar path. We just need to get a practice of writing research papers. You can choose a format, double column, whatever. That's fine. I'm just giving you here a brief outline. I do expect you to have it look and communicate similar to a research paper. Use third person. Make sure your paragraphs are correct. Blah. You have graphs where needed. A reference page, which I didn't put up here, but you need that as well. Naturally, it always starts off with an abstract, which is basically a paragraph or two explaining the entire paper. Do this one last. It just happens to start this way. Introduction. Explain the need for full system simulation. This is just for deciding what architectures are going to work best in the future. What is simulation? What problem does Buildroot solve for your needs? Explain what Gem5 is. Explain what Buildroot is. There are some good locations to put some references to those websites. Architectures of what worked and didn't work. Explain each architecture and why it worked and why it didn't work. When I'm talking about architecture, I'm talking about not just x86 ARM and whatnot, but also what GCC, Linux, kernel, libc as well. So this is where it branches into what worked and what didn't work. Experiment. Gem5 should produce some timing information. Do a couple of different simple architectures and graph the results. You could also, maybe if you, what would also be cool in this one is that if Buildroot is working for you, you can have Buildroot, GCC 7 latest version of the kernel versus, an older version of GCC with an older kernel. Just some type of timing information just to see the difference, to show that there is actually some performance difference in what's going on. I'm not this one I don't want to ask for a ton. I just want you to show me that, hey, look, you were able to get two different things up and running, and these are the results. Related work. If you find that nothing out there worked, or even if it did work, what are some alternatives to Gem5? Simple Scalar is an example, but Simple Scalar does not do full system simulation. Do go out and research a couple other tools out there. I'll tell you, last I checked, there weren't too many, but I could be wrong. Answer why one is better or worse than another. This is definitely your situation to try and convince me. If you don't like Gem5, this is your chance to convince me to use something else.
You should use something else for
Which
future
is?
students' sake.
Which is?
I don't know.
Well, this is where you have to tell me what else to use. Future work, what else needs to be done beyond what you've done in order to have better integration or capability with Buildroot? Okay, maybe you want to come up with them you did ARM, it worked well, but you didn't look into Spark that much, or x86. List what else you think should be done in order to make Buildroot easy for future students or anyone else working on this project. And then close conclusion, paragraph or two explaining the entire paper, use past tense, and then you essentially take the conclusion, copy, paste it to future tense and make that your abstract. That's how I always write a research paper. All right, so the deliverable is your final report explained earlier and any of your code on GitHub. It's due April 30th, which is during finals week, so I am not able to extend that deadline. Keep that in mind. I am not able to extend it beyond that. Teamwork, no teamwork, your work must be your own. Yep, and that final build of GCC is going to take a while. Okay, but hey, it's going. By the way, guys, that's it. There's no more homework, no more presentations.
Last class.
That's the last, yeah.
Really?
Yeah.
Oh, we're done?
Yeah, we're done.
So when's the midterm due? Quote unquote.
I mean, if you want, I'll give you another week for the midterm. I don't mind doing that. But you're going to have to get this up and going. Why, you think this is going to be helpful for the midterm?
I don't know. It's just the whole getting Gem5 to actually cooperate and run with the full system.
I mean, Buildroot is pretty nice. It's been very nice to me, a lot nicer than Gem5. I've just never tried to paste the two together.
And we can use any processor we want for this.
Yes, But keep in mind with your experimentation, you need to show that you actually use something at least semi-realistic. But I would suggest starting with atomic CPU just to see if you can get it running.
Cool.
Yeah, the time difference, just booting the 3.0
Out of order?
is like 45 minutes, where atomic's like about 5.
Also, when you have the atomic and you hit something on the keyboard, it comes back pretty quick.
If you type it in the 000, it's like you hit a key and about 3 seconds later it comes back to you.
Yeah. Yeah, so again, start with atomic. Really, you should never be, the only time you should do atomic, or 000, sorry, is once you have your environment set up to where it boots up, it runs your process, your benchmark, and then it exits or shuts down. That is what I would have your system be. And once you have that up and running is basically the only time I would have you go and do a full out of order simulation. Before then, everything should be pretty much an atomic CPU.
What kernel did you say you were running on?
Alpha.
No, like
Oh,
literally.
what kernel?
Yeah.
I actually downloaded a pre-built kernel.
Let's go see what Builder has. I haven't even looked for Alpha because I had to do it again. I had to do all of Builder by hand. I mean, for Alpha by hand. Jim, let's see, git clone build root Alpha build.
The University of Texas did
That
a
was
thing
that
years
one.
ago. And
From the
actually,
link with all the stuff. That one. Okay, cool.
They wrote a paper on it and all, but the paper doesn't get into specifics. It's more like a general thing.
Let's see if it has the option. Does it have? See, does it have Alpha? It may not have Alpha. Oh, it has Spark. Oh, it doesn't have Alpha. Oh, it has Super H. Oh, that's cool.
What is Super H?
Sega Dreamcast.
Cool.
Now, make sure you check to see which ARM it wants, Little Indian or Big Indian. I do not recall which one Gem 5 uses. But it it has to match. It's not going to work.
Yeah.
All right, so you don't have Alpha.
32-bit. Oh man, I can't believe it. That was my big problem. I was trying to use 64-bit.
Yeah, I mean,
i386.
this is, yeah, i386, and then they say 64 is down here. Yep. All right, so you don't have that. Oh, well.
So i386 is a 32-bit.
Yes. That's 32-bit.
Well, me shoot myself right there in the foot.
You can also select which core you want. Wow, that's kind of cool. Wow, that's a lot of choices. Yeah, you can do it for the 46. Let's boot everything on 46s. Wow.
Now that's 64-bit.
46? No. The 46, the 804086?
That wasn't.
That was 32-bit. Yeah, you didn't go 64-bit till, I mean, it was after the Pentiums. At Prescott, some of the cores were 32-bit.
Okay.
Yeah, it was a long time before 64-bit came out. Yeah, 60.
I can't believe I was that stupid.
Yeah, let's go with 64. Yeah, Core 2, i7, Opteron. Yeah, you don't have too many choices here. Core 7 is usually what I use. Oh, it's sad they don't have Alpha in here. Oh well. That's cool they got ARM and they got Spark. Alright. Guess you don't have much of a choice with that.
What was that? V8?
Spark. Yeah, V8. I forgot which. Yeah, version 8. Yeah, version. I think the T1's version 9, so version 8 should work. I don't remember Leon 3. What we got as a tool chain? Sure, the latest. That'd be great. Oh wow, you can even select different GCC. Huh.
That was for.
All right, hold on. I really thought there was an alpha option. I wonder if I just missed it. Did it failed. Yep, this is what happens. Am I out of space? Nope. Fatal error, open SSL bio dot. Oh, so now, and this is with open SSL, so you got to disable open SSL inside of Linux. So that version of Linux can't have open SSL unless you decide to include it inside your libc. So this is what I'm talking about, where it went all that time, and now you need to go.
So the OpenSSL, you have to go back to the kernel and disable it.
Yeah, it's either in the kernel, or there might be a tool chain option for it. Wait, isn't there security? Is it system? What was it? Yeah, you're gonna have to. No, that's not it at all. Yep. So you're gonna have to go through and find out what caused that. But if you hit make, it should actually go right back to your error. Oh, good. Well, you know what's also cool? You can, we have this thing called Google. Whoa, I definitely hit the wrong button there.
Live by Google anymore. Tracking down bugs.
So I don't have libSSL on my computer. Oh, yep, I don't have it.
And it needs it, so it's not in the kernel, it's just you didn't have the libraries, right?
Didn't have the libraries. Make. There it goes. See? Luckily, that one did not have to restart it. I didn't have to change a menu config option. If I did, it would, redo the whole thing.
Looking forward to it.
I guess after the midterm. That's what I want to see. Build, root, and alpha.
Now I've got to go back to the x86 and try it again.
Let me see. Mandatory system. I'm trying to see. Spark. Yeah, it looks like. I guess you won't be able to do alpha with builder. That's sad. Yeah, not looking like you're going to be able to. All right. Well, that at least crosses that one out real easily.
Yeah, not worried about that.
Yep. So ARM, I'd go ARM or Spark. Spark one may actually work just fine. The cool thing about Spark was that Sun released their entire design package. Like you could, towards the end of Sun's career, you could go to Sun's website and download their full Verilog package, take it, go to a fab, and they'll fabricate the processor for you. Like, they literally gave you everything.
Wow. I remember when those Spark stations came out.
Oh, yeah, yeah.
Man, they were like 10, 15 grand.
Oh, yep.
I wanted one. I talked the boss into buying one.
Yep. So the Spark support might be pretty good because they were given a full manual of the whole thing. They weren't. It wasn't like x86 where a lot of it is hidden under a long system of a long legal process. Alpha was pretty open as well. ARM is ARM's not bad.
And they were simpler designs.
Yeah, they are.
That's why I can't understand why x86 is still around and doing so much better than these
So-
other guys that were simpler and should be more
So
efficient.
the big story here is with Alpha and x86. When Alpha came out, it creamed x86. Like there was no competition. Alpha was just dominating performance-wise x86, and the reason for that is Alpha was a RISC machine, so you had very small instructions, and we did it out of order. And the nice thing about that is all those instructions very easily fit in the Tamasulu method, where you just take the instruction and then just pipe it straight to a reservation station, and you're good to go. You don't have to really do anything else. And x86 would have to, x86, the reservation station would have to be complex because of all these instructions and so forth and so on. Then Intel got a really, really smart idea. They took their complex instructions and they had a ROM that translated the complex instructions
It's basically a pre-compiler.
right into essentially alpha instructions. They called them micro-ops, but they just translated this x86 into alpha, essentially is what they did.
That's
And
still
then-
a whole nother layer.
Right, which you think would slow it down, but what happened was the x86 binary was very small because CISC compresses your instructions down. And since memory is the bottleneck, you're able to have more cache hits, or actually not have to go to the memory system as much with x86, which completely makes up for it. It actually surpasses the performance penalties of having to translate from CISC to RISC. And that's why x86 is actually faster now.
So, would you be able to show that using the Gem 5 simulator?
Oh wow. I have no idea.
Because I'm just wondering, the x86, I don't know how you would show that trade-off of accessing memory. Is that?
Actually, you should be able to. It's going to take a while to set that up. Now that I think about it, because you're going to have to compile things for each architecture with the tool chain, and Buildroot doesn't have alpha, so.
Well, ARM would be about the same, wouldn't it?
ARM. The thing about ARM though is they don't have. Okay, x86 has server chips, like big, giant, multi-core